Getting the best from Chemistry Explained needs you to participate. So write notes, complete tasks on paper or tablet. Pause and control the pace at which the lesson goes. Crucially, complete the tasks when prompted. That means pausing the lesson, taking your time, thinking the problem through. Only when you're ready, continue. Correct your work before moving on to the next slide. Qualitative analysis. Qualitative analysis assumes knowledge of the formulae and charge on some common ions. So let's start with those. The table, we have carbonate, sulfate, chloride, bromide, iodide and ammonium ions. Could you write down the formula for each ion and the charge? Pause the lesson and resume when you are ready. Okay, so if we look at the formulae, we'll see that the carbonate ion, CO3, always CO3, sulfate, assumed to be SO4. So if you see sulfate, we assume it's sulfate 6, which is SO4. Chlorine, bromine, iodine, trivial. The ammonium ion, NH4. And the charges, the sulfate ion 2-, the carbonate ion 2-, the halides are all 1-, and the ammonium ion is the only positive ion in the set, being 1+. So there are 5 negative ions, and those are called anions, and we have 1 positive ion, and that is a cation. If we focus on the anions, there's a certain sequence for which they must be tested. We must first of all test for a carbonate, then test for a sulfate, then test for the halide. The difficulty is that if you test for a sulfate first, you may have formed a carbonate, and that will confuse the interpretation. So that sequence must be followed. Carbonate, test for carbonate, then test for sulfate, then test for halide. So if you know the methods for the test for the carbonate, the sulfate and the halide, that is, you have factual knowledge of that, I suggest you pause the lesson and write that down, plus any observations. Otherwise, I'm going to reveal the method for testing for the carbonate ion, CO3 2-. You add dilute nitric acid. The observation, if there is a carbonate present, the positive observation is that there are bubbles of gas. Pause the lesson and write an equation for the production of that gas from a carbonate and nitric acid. Come back when you're ready. Okay, so the best form of the equation is in the ionic form. So we have the carbonate ion, the acid provides the hydrogen ion. So the carbonate ion and 2 hydrogen ions form carbon dioxide, and you balance the equation with water. Notice the total charge on the left hand side is 0, 2- and then 2 positives. So it comes to 0. So we've got 0 charge on the right hand side. It's a good way of checking you have the right balancing in the equation. So if you've got carbon dioxide, you've got bubbles of gas, how would you confirm that it's carbon dioxide? Pause and write down how you would do that. Okay, so hopefully you remember from pre-A-level chemistry that you pass the gas through lime water and a cloudy white suspension is formed. That is the positive conformation of carbon dioxide gas. So moving on to the sulfate, you either have met or have not met the method for testing for the sulfate, so I'll just share it with you. You add dilute aqueous barium nitrate, and the observation for the positive observation, which tells you that you have a sulfate in your unknown, is you get a thick white precipitate. Pause the lesson and write an ionic equation for the formation of that thick white precipitate. Okay, so again, we want to keep it to an ionic form, so we don't need to worry about the nitrate because it's spectating. So barium 2+ and the sulfate ion make barium sulfate. If the unknown contains the sulfate ion, then if you add barium, you will make a thick white precipitate of barium sulfate. There is no confirmatory test for that. That is itself conclusive. Now, testing for the halides, you may or may not know that you add dilute aqueous silver nitrate. Now, provided that you have followed test 1, test 2, test 3, there is no need to start the process by adding dilute nitric acid. If you are doing a separate test for a halide, not having first tested your sample for the carbonate, it's necessary to add dilute nitric acid first to rule out a carbonate, because what you're looking for is a precipitate. Unless you have ruled out carbonates, it may be a carbonate precipitate. So if you are doing a sequence of tests on the one sample, 1, 2, 3, if you are doing a separate test on a separate portion for the halide test, then you must first of all carry out the test for the carbonate, which is add dilute nitric acid. So you will see in textbooks the test for the sulfate is often begun with adding drops of dilute nitric acid. The test for a halide is often begun by adding drops of dilute nitric acid. On both occasions, the method rules out or eliminates carbonates. If there was a carbonate, you would see bubbling. So let's assume that you've added dilute nitric acid, you then add dilute aqueous silver nitrate, you form a precipitate. The colour tells you which halide you have. The chloride is white, the bromide is cream, the iodide is yellow. For confirmation, there is a definite confirmatory method here. Oops, forgot to say. The ionic equation will be silver ions plus halide ions going to form the insoluble precipitate AgX. Moving on to the confirmatory test. If you add aqueous ammonia and invert the test tube, then if you find your precipitate is soluble in dilute ammonia, then that is a silver chloride. In other words, the halide is chloride. If the precipitate is insoluble in dilute ammonia but soluble in concentrated ammonia, hazardous by the way, then you have a bromide present. If the precipitate is insoluble in dilute and concentrated ammonia, then that means you have silver iodide, so the halide present is the iodide. Those methods and observations, including the ionic equations and the confirmatory tests, need to be known. The sequence needs to be known. Test for the carbonate, test for the sulfate, test for the halide. If you are omitting the first two tests, then you must proceed the addition of dilute aqueous silver nitrate with drops of nitric acid. Similarly, if you are going straight to a test for a sulfate, then you must, as a first step, add drops of dilute nitric acid. In both cases, you are ruling out a carbonate. Carbonates form precipitates with virtually everything. So you need to rule out the carbonate before testing for the sulfate or testing for the halide. So there is the one cation to test for in year 1 of A level, and that of course is the ammonium ion. If you know the test, write it down. That's a very good way of reinforcing your recall of it. Write it down, get it out in front of you. If not, check it against this. You add the test for the ammonium cation is to the unknown. You add dilute sodium hydroxide and warm. Ammonia gas is produced. So you're adding sodium hydroxide to the ammonium ion. Can you write an equation, an ionic equation for that reaction? Pause the video, come back when you've done. Okay, so here is the equation. The ammonium ion here, plus the hydroxide ion from sodium hydroxide. I'm not including sodium, it's spectating, not involved in the chemical change, making ammonia NH3. I've only indicated the one state symbol because that's the important point. Ammonia comes off as a gas, and you balance with water. There is a confirmatory test that is expected. Think it through, speak it out or write it down if you know what it is. But it is that ammonia gas turns damp red litmus paper blue. So if you dangle a piece of damp red litmus paper into the top of the test tube in which your ammonium and sodium hydroxide is reacting, you should find, if you have ammonia, that red litmus paper will turn blue. As before, this is very factual, it needs to be known. So for my final slide, just the obvious statement that to consolidate you need to practice, you need to find problems from whatever source you have available to you, but those sources which have comprehensive answers are the best. So attempt the problems, check your answers. Move on when you are being consistently accurate and complete in your answers. Choose the next topic that you think for you is the one you need to focus on.